Yes. A very good afternoon to one and all. A warm welcome to all our participants for today's webinar on data analytics and basics of ETL and industry perspective. So we have with us Mr. Abhiranjan Jagannath, a proud alumnus from the Department of Computer Science and Engineering, Vidyavardhaka College of Engineering, who's right now an application development manager at Accenture, Australia. He has a wide experience with respect to the industry expertise in some of the renowned companies like Subex and Infogix. A very warm welcome to you, Abhiranjan. You can take over the session.
Thank you so much, ma'am. Hi, everyone. So I think Pooja ma'am just gave my introduction. So I would like to just start off by saying that I have been an alumnus from 2005 to 2009 and currently working for Accenture as an app development manager. So it has been my pleasure and an opportunity that I've been blessed with is to work on various domains like telecommunication and data analytics domain. So I'm sure you guys would have actually had a lot of sessions on data analytics using Python, using R programming, and many other avenues that we have. What I intend to actually take you guys through today is the very basics of ETL and importance of data analytics. So we often miss the concept of having an understanding of basic ETL and how important the data analytics is around that. So what I would like to do in this session is to walk you through a very basic scenario. So I'll present you all with a scenario and then we can walk through that. So let's just begin. The first thing is, so what is data? So I'm pretty sure, by now, data is the big word, it's the buzzword, and big data analysis and data is the buzzword that's going on. But in true sense, in the industry, when you guys get placed and you go on to different companies to start working, you would realize that it's just not the curriculum or the theory that you can directly implement and start putting things together. Of course, it is very important to know all of the technicalities behind it, but just to touch ground on basics. What's data? We have data in all walks of life, right? So starting from if I'm just looking around me here, so there is data on the telephone. So we have been making calls, we are sending text, we are downloading stuff on the internet. There is a lot of stuff going on. There's electricity and there is bill payments going on at the background. You go out to pick a coffee, you will be paying through the payment gateways, and there's a lot of data that is getting churned through. And as long as data remains data, it's just noise. So you won't be able to make sense of what data is trying to tell you. So in order to actually make sense of it and to see, analyze, and predict what our future roadmap is going to be, we need to do some good amount of processing on it. So when I say processing, it can start directly from extraction of the data set from the source systems, and then massaging the data set, enriching it with the required dimensions, and putting things together based on the requirement that we have, and making it sensible, usable data. That is when you will really reap the benefit of having done some data analysis on it. So from noise, we can collect all of the data and process it and put it out in a sensible format. That is the sensible, usable data set that you have is the true data that you would want to have in any project, in any implementation. So having said all of this, let's go through this scenario, right? So I'm sorry if I'm looking at two places because I have two screens here, and please bear with me. So The scenario is the operational head of a supermarket chain, let's say, Big Bazaar, wants to improvise on the inventory management based on buying trends of the customers. So that's the scenario. So let's imagine for a moment that you guys are placed and you have joined a company, and now you are in the team of data analysts and implementation consultants who are supposed to meet this requirement. And the client comes up and says, hey, this is my requirement. Um, what can I do to improvise on my inventory management? So inventory is nothing but the stock that every supermarket would keep, and it basically stocks all of the products that are being sold. So if this is the scenario and this is the requirement, in the real world, in the industry, where would you start? So this is all you would get to start with, right? Just one requirement. So the question is, where would we start? So what is needed? So the first thing that we need to ask ourselves is, what is needed to meet this requirement? Definitely we need data. So, but what sort of data do we need? A supermarket, and especially a chain of supermarkets, can have a wide variety of data that is residing in their servers and their databases. So what is it that we need from that huge set of data to actually meet this requirement? So we need buying trends of customers across locations. So people who are walking in, picking up stuff, paying for it, and buying all of the products, we need their buying trend. We need the categorization of goods that they are buying. What sort of goods are they buying, and how are they spending? So on what sort of goods are they spending? And we would need to have a range. So that is very important. So usually data analysis can be done on a smaller data set, but it is best done on data set which dates back to 3 years or probably 5 years, to get to know what the pattern is. So without making decisions based on patterns, it wouldn't be the right decision, or most likely wouldn't be the right decision. So in this scenario, you are the team of engineers, data analysts who are working on this. We have identified that this is what we need: buying trends of customers across locations, category of goods, and range of historical data to start with. Typically what will happen is, we will need to sit with the client, with the business team, so to say, and ask them the right questions. We have to ask them where all of these data is residing. So more likely than not, the billing will be happening through a separate application, and the categorization of goods, or the product catalog as they say it, will be residing in a different application, because that has to be managed by a separate team who knows what's there in the inventory, who knows what's coming in and what's going out. Billing is a separate application, and likewise, all of these things coming together will be an integration piece that would be put in together. So if you have to get information from various sources, and supplier information is from another source, because there is a supplier management system usually that comes into picture, we have to ask the right questions. So as a data analyst in the team who is trying to get to this requirement, you'll be asking these questions to the business team, saying, where is it all residing? How can I get that data, raw data, and where can I load them into? What can I do on top of it? What is the logic? And all of those questions will follow. So let's move on to the next slide. This is a very basic primary view of something we usually call as ETL. So E stands for extraction, T stands for transform, and L stands for load. So what is extraction? So as I was just saying, when you ask these questions to the customer, where is the information residing? So in this scenario, what do we need? We need customer information. We need product information. We need the store information. Where is the sale happening? Which store? Is it in one state or the other? And what is the billing history across multiple years? are there any discounts or promotions or any other bundled packages that is being offered, because of which the sales might be going up or maybe going down? What is the supplier information? So who is supplying all of this products for the supermarket? All of this information, surprisingly, will be in different applications. One application might be based on SQL, one might be based purely on Oracle, the other might be based on the cloud, and it might be using, let's say, Microsoft Azure or Amazon Web Services, and it might be residing in the cloud. So there are on-premise applications, there are cloud applications interacting with each other. So a whole host of input data source has to be extracted. So in the real world, we will have to come up with something called as an interface design specification. So what is an interface design specification? So basically, it is an agreement between source system and the consumer system to say that I would like to consume the data in this structure. So customer information. So let's say it is a database. So the interface specification document says that I will be connecting to that database through, let's say, a JDBC link, and I will be picking up information from all of these tables that is there within that database. So one of them might be customer information and the other might be billing history. So that is the interface specification, and we all have to adhere to it, right? The next thing that would be of importance is that something else, let's say, for example, discounts and promo information might be just an Excel sheet that some team is managing manually. You would want to pull in that Excel sheet into your extraction logic. So all of the information extracted from various different sources is the extraction step. So extraction step itself is actually divided into multiple stages. The first one is to actually know where all of the information is residing. That's step one. So let's come back to this flow diagram as and when we actually talk to it. Let me just move on to the next slide, which will give us more information on what we are trying to do here. So this is the extraction, right? So now customer information, what are the things that will be there in the customer information? So it could basically be very specific, personally identifiable information about the customer. Now, one thing that we need to keep in mind is that it should be very sensitively handled. So in reality, if you are a team of data analysts who are trying to implement this project, the moment you see customer information, it is a red flag. The next thing is product information. What's the product name? What is the barcode? What is the expiry date? How much of stock is available in the inventory? All of that is product information. What is the categorization of the goods? Store information, the location of the store, what's the size of the store, what is the inventory in that store, and all of that is store information. Purchase, billing, history, that is the most important bit in this requirement. So high amount of concentration should go into the billing history. Basically, billing history is when each and every customer buys products from the store, there will be an itemized bill that will go out, and all of that information will be stored. So we need the billing history to relate back to all of the other information that we have here. Discounts and promotions and supplier information. So all of this, once extracted using any technology, which we will go to shortly, is the extraction step in this ETL. Things to remember while extracting the data. First and foremost is to scrub all sensitive information, personally identifiable information from the input data set. That might be customer name, age, date of birth, postal address, all of these, telephone numbers, all of these are personal information. So we have to scrub all of these before actually starting to handle the data. This is a very important step in the industry, in the real world, which might not be emphasized enough until now. So it is going to safeguard the project from legalities, wherein handling sensitive information in most of the domains like telecommunication, healthcare, banking is of utmost importance. So, what do we mean by scrubbing? Scrubbing can be done in various ways. We can encrypt it. So that is the encryption. Is encryption required? So should the personal information be visible to the users when the data is in rest? That is, if the data is stored and is in rest in some database, and if somebody is able to access that database or wherever you have extracted that data into, should it be encrypted while it is in rest? And when the data is in transit, should it be encrypted? So even though you have encrypted the data while it is in rest, it is very important to encrypt the data while sending it across. Now these are the things that come into picture while deciding what is the tool that we need to use to do extraction. There are very limited tools and avenues for us to do encryption while the data is in transit. um, Cloud applications and on-premise applications have to communicate over the internet. So achieving encryption when the data is in transit can be a challenging concept. So that is the most important thing that we need to keep in mind while actually implementing an ETL project. The next thing is, once we have all of the sample data sets, so what would we usually do? We would just say, provide me with all of the sample data sets that I can take a look at and interrogate. So once we get the data, what do we do on it? We need to check if the data that we are going to get in the future based on the sample is of quality. So can we base the project on that data? Any data analysis project is based on the quality of the data, garbage in, garbage out. So the moment we get hold of sample data in the real world, in the industry, we need to check if there is anything missing that is actually required for us to implement. So in this case, what would that be? In this case, it would be basically customer information. Though we would be encrypting it or scrubbing it, we need that. We need the billing information for sure. We need the product information because we need to know what is the trend, because that is what the operational head of the company is asking us. He's asking us, what is the trend? What can I do to improve my inventory management? So we need to know what products are being sold. So we need that for sure. So if there is any information that is missing in all of the data set that we are getting in, that is a red flag. The other thing is unexpected data sets. So when we are dealing with a lot of data, when we are dealing with big data, uh, there can be certain things that are unexpected in certain formats. So we need to look for those. For example, let's say we are expecting all numerals in a particular field in the data set. However, if that field has alphanumeric characters, which is not expected, it might be a problem going further, because we might not be able to join that data set on any other data set to make meaningful sense out of it. So we need to see if there are any unexpected data sets that are coming in. If yes, then it's a red flag. So the next thing is format misalignment. So the interface agreement document says that you will have all of these fields defined as characters, all of these fields defined as integers, all of these fields defined as dates. So is there a format misalignment from what is being agreed and what is being sent? That is another important thing that we need to check. And key field integrity. So customer ID is a key field, because we would want to know which customer spent on what item. That is the whole crux of this scenario, right? So key field integrity is very important. Is the key field available in each and every row of the data? Are we able to join it on the other sets of data that we have? Is it available in all the sets that we intend to join? This is something that we need to interrogate and check and raise a red flag if there is something missing. The reason, just going back to the reason why I'm talking about all of these things. So in the real world, the project implementation is actually going to be the most strenuous, difficult bit of the whole thing. So If we collect the requirement well, if we interrogate the data well, if we know what's missing, if we know what's supposed to be in there, the rest of the project becomes more easier, right? And the last but not the least is the access control. While providing access control, we have to use the rule of least privilege. That is, start from no access. So nobody gets access to start with, and then we can decide on who gets what access and at what level. Whether you can only read the data, whether you can actually read and write, whether you can read, write, delete, and do data manipulation. So all of these accesses are supposed to be provided based on very careful interrogation. So rule of least privilege is something that we need to remember. All of that we just spoke about is extraction. So what do we have so far? We have all of the source systems. We have an interface agreement document. We know that the data is in good quality. We have raised red flags wherever it is not. We know whether we are encrypting the data or we are not encrypting the data based on the sensitivity. And we have given good access control. So once all of this is set, this is when the design or the extraction logic is set. That is the E of the ETL. So moving forward to the next one is transform. Now, transform is the engine of the entire application. So yes, we have got all of the information, but what do we do with that? So that is what transform does. So the actual business logic is implemented in this bit. So we may use any technology to do this. We may use R or Python or SQL or Azure Synapse or anything like that. But this is the engine. So we need to know what exactly is the requirement. So we have to go back and forth to the business, asking for the requirement, getting clarifications on it. What is it that is exactly required? Okay, so the billing information is available, but it's not available for a certain set of customers. Why is it so? All of that fall into this bit. So once we know what we need to do, we have to implement that logic. It can involve derivation of required metrics and dimensions. So let's say, for example, you only have customer and the billing information, but the client comes up and says, oh, you know what, I also need to know which aisle was this product set up in. So I'm sure you would have observed that, placing the product in a supermarket is very important. So probably they would now want to know where to place this product to make the proper sale. So the operational head comes up and says, please add the placement of the product as well, along with the billing and the product information when you give it to me. So we will have to derive that, or we will have to enrich the data to also show the aisle information, where it was placed and how it was accessible to the customers who are walking into the store. So all of this business logic comes under data enrichment. So we will have to join with various other tables, and we'll have to merge and slice and dice the data set in such a way that this information is available. Within this transform engine comes a very important concept called performance tuning. So in the real world, if you are working on this project, it's very important to meet certain timelines. So it's not enough if we are actually reaching the requirement. It is very important to reach the requirement within the given timeline. So performance tuning of the implementation becomes very important. So what are the indexes that are supposed to be there? Should there be partitions on the table based on the dates for easy access and quick access of the data set? Can we actually distribute the data in such a way, if we are working on Hadoop, or if we are working on cloud implementations with file system based databases, can we actually distribute the data sets in a hashed manner or in round robin fashion to be able to better access the data and quickly access the data? So what is the time taken by this engine to churn out and reach the requirement? That becomes very important. So all of these things put together will actually make the logical bit of the project. So that's the T, which stands for transform. And then comes load. So loading is the next important bit, and more often than not, loading is actually given lesser importance. However, it actually proves to be a very important piece of the puzzle. So when we say loading, we are basically loading all of the data that we have churned out so far during the transformation into our output data stores. So output data stores can be a database, it can be an Excel sheet, it can be Power BI, it can be any other business intelligence tool or residing place where we would want to show the data or tap the data from and show it in a reporting tool to the client or to the business stakeholder. So loading becomes very important because it also guides the timeline with which we will actually load the data into the output data store. So now coming back to our example. So in a supermarket, the sale is happening on a daily basis. It is so even while this application or this transformation logic that we have implemented is running, in parallel, sale is still going on. So it becomes very important to know when we can actually cut off and say, okay, I'm going to load my output data store now. It has to be during the day end when we are actually doing the closing balance, or when we are actually trying to come up with the opening balance. During that time frame, we will have to load the data into the output and say, this is what I know up until now. So loading has a lot of things associated to it. Along with loading it to the database, it has a lot of timing considerations that needs to be given. Once the load is complete, it would essentially mean that extraction, transform, and load, all of the three components of this data migration, data analytic project is complete. But is the requirement met? So the requirement is still not met. The reason being, all we did was we extracted the data, we massaged it, we transformed it, we sliced and diced it, and we have stored it in an output database. The requirement is still not met because we still haven't given all of the information that was requested by the business stakeholder. What do we need to get there? So before we actually go on to see what we need to do after loading the data, I would like to walk you through some of the basics of tool selection. So yes, we discussed about all of this, but how will we achieve this? Based on what technology will we achieve this? What are the considerations that we need to have before selecting a tool to actually implement a project like this? So that's the tool selection basis. So first and foremost, the focus here is on an actual project. So we constantly have to remind ourselves and imagine that we are actually trying to implement a project. Somebody has come up and said that, please do this for me. And the first and foremost thing that we need to consider is cost effectiveness. So there is a budget. We are always driven by a strict budget that the business might have, that the client might have. That's the first consideration we need to give while selecting the tool. The second thing is performance. How well or what is enough for this project? What is the amount of data, volumetrics of the data that we have? Do we have 3 million customers for the supermarket, or do we have just 3,000 customers? Do we have a lot of stores, 135 stores across 75 locations, or do we just have 4 stores across 2 locations? So based on the volumetric, we will need to see which tool will perform better. So performance comes into picture. The third thing is on-premise or cloud. Now that is a very interesting thing that is off late picking up. So there are two types of implementation that we can do, right? So on-premise would usually be running on SQL Server, Oracle, and things like that, and the data will reside in the on-premise network. It's not on the cloud. So however, there are a lot of advantages of having the implementation done on the cloud, and there are advantages of having the implementation done on premise. On premise will give you more control over the infrastructure and the data, and cloud comes with its own trade-offs. So we need to decide on that. And then ease of usage. Ease of usage is, nowadays there are a lot of tools that will enable even a business user to write transformation logic. So there is really no necessity for us to actually get into any specific language. It will allow you to do all of the transformation graphically. You can drag and drop all of your joins. You can say inner join, left outer join, merge, union all, and you can even do data profiling graphically. So there is a graphical user interface that will be provided in most of these applications that are high-end applications, and you can do it. So ease of usage comes into picture here. And then comes elasticity. So elasticity is again a new thing that is being spoken about. And elasticity is whether your application will be able to scale up or scale down, horizontally or vertically. So what do we mean by that? So let's say, for example, again coming back to the supermarket example, day in and day out, supermarkets are doing sales. So when we are trying to run all of our transformation logic on the data set, let's assume that there are 3 million customers for this supermarket that we are talking about. So each customer is buying, let's say, 10 products. So you can imagine the amount of data that is being handled by all of the application behind the scenes. So if we have to actually churn out the output, we will need the infrastructure to decide whether it has to scale up or scale down to make it more cost effective. So during the afternoon, probably the load on the application is lesser, and during the evening, the load on the application is higher. So will the infrastructure be able to cope up, scale down based on the load that is being applied on it? So that is elasticity. We can achieve elasticity using cloud implementation. However, it is almost not possible to achieve that elasticity on premise. So if the infrastructure is in your control and there is no means to actually increase the infrastructure and decrease the infrastructure based on the volume that we are processing, that means that there is no elasticity. So cloud comes with elasticity. And the last but not the least, since this is an industry perspective that I'm trying to give, even though you would like to go with a particular tool, talent availability in the team will also play an important factor to choose the tool. So based on all of these things, we need to select the tool. So here are some tools that I have listed out. Definitely these are just few, and there are many other tools that are available. So there's SQL and Python, Microsoft Azure cloud implementation, which can be coupled with Snowflake and Data Factory. And we can also have the Azure Synapse Analytics to do the slicing and dicing. And likewise, there are, parallel things in Amazon Web Services and Google Cloud that also provides all of these tools to actually slice and dice the data. So if you ask me, if you are an engineering student and you're, studying final year or, the penultimate year, I would suggest that you guys can actually brush up on any of these and start learning these tools, any one of these tools or something else that might interest you as well, to actually have an edge while coming out into the industry. So these are really the very highly desirable skills at this point in time. So now, what have we done so far? So we extracted, we transformed, we loaded using all of these tools based on all of these criteria. So we have selected our tool and we know what to do. And let's say we have implemented and we have loaded the data. So this end-to-end diagram here gives you that summary, right? So source systems, it can be in any format. It can be a database, text file, Excel, a JSON message, an XML, a CSV, or a DAT file, and many other formats. It can be in any format. We have to extract it. While extracting, we need to make sure that we have the data quality. We have done all of the validations on all the dimensions that we need, assurances to make sure that 100 records were sent in, 100 records were loaded. Because if we are dropping records in between, we are basically losing data. So we need to make sure that we have not lost data. There is no data leakage. And then integrity checks for all of the primary key fields and things like that. That is extraction. Transformation is business logic implementation, rules joins, derivations, data manipulation, data aggregation, which is quite important because you cannot really give the data to the client at a detailed level. So as a client, he or she will not be able to make sense of the data if we give them 3 million records or 3 million rows of data. We have to aggregate the data to such a level that somebody can actually take a look at it and make sense out of it. And then performance tuning. So all of this is transform, and then comes load. Obviously, you can choose the tool again, and you can load it into any one of these tools to store the data. Once we have done all of this, what is it in this scenario? So again, I'm coming back to the scenario. So you all are data analysts and engineers who are trying to implement something for an operational head of a supermarket. And he has asked how to improve the inventory, right? Inventory management process. So what will we provide? So what information can we provide this to the operational head? Each customer's bill has multiple product line items, because if you go into the supermarket, you won't buy one item, right? You will be buying maybe 20 items. So it'll have multiple product line items. The final output should be at that product line item level, because you would want to actually have that granular level visibility as to what item was purchased by each customer, correct? So we will be providing that. Product information and billing information put together. So yes, the customer bought this product for this price. Was a discount applied? Was the product expired or not expired? Was that customer a loyalty customer, for example? All of that information needs to be put together. The location of the customer. So now this plays an important role. Now be very careful here. I have only taken the location of the customer, but no other personally identifiable information, just the postal code to make sense of where are your customers coming in from, right? Coupled with the billing information. Product packaging information probably could be very important, because there can be last minute requests, and let's say we want to know whether customers are actually choosing to be more greener. So we would want packaging information. Cancelled bill status, maybe. So all of these things are what I have put together. So um, as viewers, probably you might have more ideas as to what you would put together for the operational head to make his or her decisions. So cancelled bill statuses can be included just to see what's going on. Aggregated view of revenue by category of the product can also be provided. So these are the things that we will be providing the operational head, right? In this scenario, just in this very basic scenario. Once we do this, what can he or she infer from this information? What is the insight that can be actually inferred out of this information? So let's just move on to the next slide. These are all again assumptions, and I would like to just point out a few. Of course, when you really implement a project, you will be knowing more. So let's say there was a steep reduction in food sales, coupled with a steep increase in seeds sales. So, a supermarket can have a seeds section wherein you can actually buy the seeds and sow it at home and grow it. What can be inferred from this? We can infer that more number of people are probably attempting to do home gardening, right? And what does it tell me that what can I do about it? So inventory can actually have more gardening tools, potting soil probably, and more gardening equipment. So that can probably boost my sales in the near future. And I might actually be able to sell more of those items, right? There was a slight increase in electronic sales. So now if there was an increase in the electronic sales, it doesn't necessarily mean that people are buying more electronic sales, because given the current situation, probably mobile sales and laptop sales might go down. But if you drill down to the details of each individual product line items, you might see that keyboards, mouse, webcams, and batteries were actually sold more in the recent past. So it can be inferred that more people are working from home, like the way we all are, and you can probably increase the inventory for all of those home office support utilities that can actually boost your inventory in the right direction. There was a steep increase in hygiene products, of course, given the current situation we all are in. So if more hand sanitizers were sold, if more soaps were sold, probably you can improvise on sanitization and hygiene products. So all of these are insights that can be inferred from the data set that we have provided the operational head. Now, again, this is a very basic example that we are trying to discuss here, but the intention of the exercise is, if you get placed in a data analytic firm, or if you get placed in a firm where you get into a project where you have to implement an end-to-end ETL project, these are the steps that you have to follow. That is, talk to the customer about what is the requirement, understand the requirement, jot down or get to know what input that is required for that requirement to be met. Where are all of the inputs for you to actually tap it and extract it? How to transform it? What and how to load it? What is the tool that you're going to use? And of course, along with it comes other things like the software life cycle management, things like testing it, and there are iterations. You can follow agile methodology or a waterfall approach and all of that. So I'm just trying to put together a view of a small project that is really implemented. So this is what we would be providing the operational head, and the inference from all of this information will be these, possibly these, right? And with respect to the canceled bill status, I would like to go back to that. So let's say, and the reason why I just added this information here is that maybe the customers are actually canceling the transaction midway because probably all of the amounts were less than, let's say, 100 rupees. And why is it so? Probably because you're not accepting credit cards or debit cards for all of the transactions that are below 100 rupees. And hence all of those are being cancelled. So that can probably give us an insight to say, do we need to really talk to the banks, and does the supermarket operational head talk to the banks or the financial heads to say, hey, don't reject anything that is below $100, please do accept all cashless transactions as well. So these are the insights that can actually come out of the data, right? Now, having said all of this, I would like to just take you through what really did we discuss. What did we finally achieve? What we finally achieved is data analytics from 15,000 feet, right? From a very, very high level, from a bird's eye view, what we achieved is data analytics. We finally did data analytics. And how did we do that? All of the things that we discussed now links back to these points that I've mentioned in this slide, right? So data mining, pattern discovery. So what did we do? We just went back in history. We saw all of the customers who have spent money in the supermarket, and we identified the pattern in which they are spending, right? What happened in the past? What happened over the months? In March 2020, did we see a dip in the sales? All of that is pattern discovery, right? The next one is statistical. So for every single pattern discovery that we did we have statistics? Did we have quantities, the number sold, the count of it, the amount spent? All of that is statistical analysis. Then we did a diagnostic analysis. Now, diagnostic analysis and predictive analysis and prescriptive analysis are all after facts. After you load the data into your output data store, these are the things that we need to do in order to make sense of that data, to make sense of the data and to actually churn out a roadmap. We need to do all of these analysis. What is diagnostic analysis? Diagnostic is, why did it happen? So yes, the customer sales went down. And why did it go down? It's probably because of the current situation. And did it go down for food? Yes. But did it come up for seeds? Yes. And what does it in? So these are all diagnostic analysis that we can do on the data set. Predictive analysis is, will this continue? Will this pattern or this trend continue, or is it a one-off case? Is there something that we can identify that, okay, so let's say, if we actually take out all of the data of tourists visiting Mysore Palace, for example, and if we take that data for the previous 3 years, we can actually see that there is a rise during Dasara, right? Quite obviously, there will be a rise during Dasara. And If there is a rise, if there is a rise in that, what does it mean? It means that there are more people coming in, there are more sales happening. Is there, more grievances, more complaints during that time? If yes, what does it tell me? It tells me that there needs to be more crowd management. There needs to be probably traffic light signaling adjustments to be made because there will be more traffic. All of this is, will it happen again? And what do we do if it happens again? So in our current example, or in the scenario that we discussed, obviously the operational head will be improving the inventory management. He will be asking suppliers to, say, give me more of these items, and probably you can reduce these items. The location of the supplier probably will tell him where there is a lockdown, where there is no lockdown, whether the supplier can actually give the supply to him or not. So there can be a wide range of analysis that can be done. So just a note on the prescriptive analysis. What do we do if it happens? This is the bit which is not explored in the current world, because this is the complicated bit. What should we do if a certain pattern is occurring again and again, can actually lead us in the direction of machine learning and artificial intelligence? So we haven't reached a stage where our applications can automatically take action based on the pattern. So we are slowly taking baby steps towards that. So prescriptive analysis is very closely linked to machine learning and artificial intelligence. So to all of the students out there, what I would like to emphasize again is, this is an interesting domain, data analytics and ETL and all of that, and predictive analysis and prescriptive analysis and all of that. So if you would want to if you want to learn more about it, please start preparing yourselves and start learning the tools around it, start learning cloud applications and its implementation. And you would definitely be better equipped to hit the ground running when you get into the industry. So that is what I wanted to cover in this basic session of data analytics and ETL. So, yep. Thank you everyone for your time and patience. I hope this was helpful to all of you. And I would be handing it over to the moderators. Thank you very much.
Hello, Abhiranjan.
Hello.
Thank you so much for throwing light on the most important aspects of the ETL and its application with respect to data analytics. A few questions from the perspective of our upcoming graduates. What are some of the good opportunities one would see after specializing in data analytics?
So yes, so basically, I think all of the projects are now slowly moving towards data analytics and what we can actually infer from it. So when we talk about opportunities, there are a lot of companies out there who are looking for, students who are well equipped with the tools that are required to do the data sciences, if I can just categorize it like that. So my advice would be, it is best if they can start brushing on all of these concepts. There's a lot of opportunity out there, and data is everything. So there was an interesting, talk very recently that I was involved in, which actually told us that even if there is recession, one domain that would probably still be floating is the data analytics domain, because um, even for us to actually come out of such a situation, we would need to do some data analytics. So I would say this is the hot topic and a very good field to be in. So my advice would be to go towards that, ma'am.
Okay. Thank you, Abhiranjan. We don't see any more questions here in the session. We thank you on behalf of the entire Department of Computer Science and Engineering, VVCE, for being with us, for sparing your precious time to be with us, and for having thrown insight into all the basic aspects of analytics and ETL. Thank you so much, Abhiranjan.
Thank you so much.
Also on behalf of the coordinators, we would like to remain thankful to the management, principal, HOD, and the entire Department of Computer Science and Engineering for having extended their full-fledged support in organizing this event. Thank you so much, one and all. Thank you, Abhiranjan, once again. Thank you to all our
Thank you.
participants for this webinar. Thank you.
Thank you. Have a nice day.